So a homogeneous system is given here. We need to find out the solution of the system. So what is the first step? We have to write down the
coefficient matrix.
Yes, we have to write down the coefficient matrix. The coefficient matrix is A equal to 1, 1, 1, 2, 1, minus 1, 3, 1, 1. And next is we have to reduce this matrix into echelon form. So what is the echelon form or what operations we can use to reduce it into echelon form? Mark the first leading coefficient, which is 1, and make all the entries below it as 0. So what are the operations? R2, we have to change R2 and R3. R2 changes to
R2 minus 2R.
R2 minus 2R1 and
R3 minus 3R1.
R3 minus 3R1. So this will become okay. What is the next leading coefficient? We have to mark the second leading coefficient, which is minus 1, and make all the entries below it as 0. So we can apply the operation R3 equal to R3 minus 2 R2. So this becomes 1, 1, 1, 0, minus 1, minus 3, 0, 0, 4. So now you can see that this matrix is in echelon form. So what is the rank of this matrix? The rank of the coefficient matrix will be
3.
rank A will be 3, which is same as the number of variables. So what we can say? It has only the trivial solution. Trivial solution means x, y, z will be 0, 0, 0. That is the only solution for the given homogeneous system. Okay. Another example. Okay. Another homogeneous system is given. The equations are 2x plus 3y minus z plus w equal to 0, x plus y plus z minus 2w equal to 0, z plus w equal to 0. So there are 3 equations and totally there are 4 variables. So we need to check whether it has infinite solution or trivial solution. For that we will write the augmented matrix. So augmented matrix will be 2, 3, minus 1, 1, 1, 1, 1, minus 2, and the last row, that will be
0, 0.
0, 0, 0, 1, 1. Okay, now reduce this matrix into echelon form. So what operation? What is the first operation we can apply?
By exchanging row 2 and row 1.
Yes, we can interchange R1 and R2 because in the second row the first element is 1. So we can interchange R1 and R2. So that becomes 1, 1, 1 minus 2, 2, 3 minus 1, 1, 0, 0, 1, 1. So now mark the first leading coefficient and make the below entry as 0. So we can apply R2 equal to R2 minus 2R1. So there is no change in the third row because the first element in the third row is already it is 0. So we don't need to apply any changes. So R2, the only change happens in R2. So which will be R2 equal to R2 minus 2R1. So it will be 0, 1, minus 1 minus 2, that is minus 3, 1 minus minus 2, that is 3. Then 0, 0, 1, 1. Okay, now is it in echelon form? What you can say? Is this matrix is in echelon form?
Yes, sir.
Yes, it is in echelon form because the leading coefficients, look at the leading coefficients, those are in increasing order. The positions are in increasing order. So this matrix is in echelon form. And what is the rank?
3.
Rank equal to 3, which is less than number of variables. Number of variables is 4. The variables are x, y, z and w. There are totally 4 variables, but rank is 3. Rank is less than number of variables. So the homogeneous system, given system has infinite solution. So how will you find one solution? A particular solution. There are actually infinite solutions. We need to find out a particular solution from that infinite solution. For that, we need to identify the free variables. So how will you identify the free variables? We have to look onto the echelon form of the matrix and look at the column at which there is no leading coefficient. You can see at the fourth column. Fourth column there is no leading coefficient. So what is the free variable? The first, which one?
Excuse me, sir. In the last column, that it's 4, no, minus 2, 4, 1. No, 5, minus 2, 5, 1.
Which one? Minus 2. Okay, this one. R2 minus 2. Yeah, that is 5. Okay. Yes, that is 5. Okay. So now, anyway, the rank of that matrix will be 3, which is less than number of variables. So it has infinitely. Okay, if rank is less than number of variables, there are infinitely many solutions. Now to find a non-trivial solution, we need to identify the free variables. So what is the free variable here?
W, sir.
W. Yes, because the first column represent X, the second column represent Y, and the third column represent Z, and the fourth column that actually represent W. The fourth column doesn't have a leading coefficient, so W is the free variable. Okay, so we can substitute arbitrary values for W. So I'm going to substitute W is equal to some value 1. Okay. You can give any values for W. Now we move on to the last row of the echelon form. From the last row, what is the equation corresponding to the third row. From R3, what is the equation?
Z plus W.
Okay. 0x plus 0y plus 1z plus 1w equal to 0. That is z plus w equal to 0. We know that w is equal to 1. So z plus 1 equal to 0. That implies z equal to minus 1. So we got the value of z. Now we will move on to the second row. So from R2, we can write the equation corresponding to R2 will be y minus 3z plus 5w. Okay. We know the value of z and w. So substitute into this equation. So y minus 3 into minus 1 plus 5 into w. W is 1 equal to 0. So y plus 3 plus 5 equal to 0. That implies y equal to minus 8. So we got the value of 5. Now move on to the first row. From R1, the equation will be x plus y plus z minus 2w equal to 0. So substitute the value of y, z and w. So it will be x plus minus 8 plus minus 1 minus 2 into 1 equal to 0. So that implies x minus 9 minus
11. X equal to 11.
x minus 11 equal to 0, x equal to 11. So a particular solution. So solution will be x, y, z, w equal to 11 minus 8. What is the value of z? Z is minus 1 and w is 1. Okay. So this solution is one among the infinite solution. Also we can find the general solution. So how will we find the general solution? To find the general solution, we have to convert the basic variable in terms of free variable. Here the only free variable is z. So the free variable is z. What are the basic variables?
W, sir.
Oh, sorry. Free variable is w and basic variables are x, y and z. So we have to convert this basic variable in terms of w. So we will use the echelon form. Again, we can use from R3. What is the equation corresponding to R3? Z plus W equal to 0. So from this we can write Z equal to minus W. So we will move on to R2. So from R2, the equation corresponding to R2 is y minus 3z plus 5w equal to 0. So y equal to 3z minus 5w, and we know what is z. Z is minus w. So 3 into minus w minus 5w. So that is equal to minus 3w minus 5w, which is equal to minus 8w. That is what. So we got the value of 5. Now move on to R1. From R1, the equation is x plus y plus z minus 2w equal to 0. So what is x? X equal to 2w minus y minus z, that is equal to 2w minus y is minus 8w. So minus into minus is plus. So plus 8w minus z. Minus z. Z is minus w. So minus minus plus w. So that will be 11w. So x equal to 11w, y equal to minus 8w, and z equal to minus w. So the general solution will be xy zw equal to 11w, 8w, sorry, minus 8w, minus w, comma w. That will be the general solution. So if you substitute arbitrary values for w, you will get different solution. For example, if we substitute w equal to 1, we will get 11 minus 8 minus 1, 1. That is one solution. If you substitute w equal to 2, we will get another solution, 22 minus 16 minus 2, 2, etc. There are infinitely many solutions for the given homogeneous system of linear regression. So this is how we find the solution of a homogeneous system. So like I said, there are two possibilities, only two possibilities. If first possibility is it may have only trivial solution, or the second possibility is it may have infinitely many solutions. So first possibility happens when the rank of the coefficient matrix is same as the number of variables, and the second possibility happens when rank of the matrix is less than number of variables. And to find a solution for the second case, that is, if it has infinite solution, to find a particular solution, we will identify the free variables and substitute arbitrary values for the free variables, and we will get a particular solution for that system. To find the general solution, we will just convert the basic variable in terms of the free variable. Okay, is that clear?
Yes, sir.
Okay. Next is the case for non-homogeneous system. So we have discussed Gauss elimination method for homogeneous system. Now we are going to discuss a Gauss elimination method for non-homogeneous system of linear regression. So a non-homogeneous system means a system which is of the form Ax equal to b, where b is not equal to 0. Okay. Such type of equation is called non-homogeneous system of linear regression. So for the case of non-homogeneous system, what are the possibilities? There are three possibilities. First possibility is a unique solution. And the second possibility, infinite solution. And there is one more possibility, that is no solution. Or we will say that inconsistent. Okay, these are the possibilities for non-homogeneous system of linear regression. So to identify these possibilities, what we are doing is we will write down the augmented matrix of the homogeneous system. Suppose that we are given a non-homogeneous system which is of the form Ax equal to b. Then we will write the augmented matrix. Augmented matrix is denoted by AB. Then we will reduce this augmented matrix to echelon form. Okay. From this echelon form, we can obtain the rank of A and also rank of AB. That is, we can find rank of the coefficient matrix and also we can find the rank of the augmented matrix. If rank of A not equal to rank of AB, if rank of A is not same as rank of AB, then we will say that that system has no solution. Okay, the next possibility is rank of A equal to rank of AB. Rank of A is same as rank of AB, which is also same as number of variables. Then that system has unique solution. And one more possibility is there. If rank of A equal to rank of AB, which is less than number of variables, then we will say that the system has infinite solution. So these are the three possible cases for a non-homogeneous system of linear equation. What are the three cases? It may have unique solution, it may have infinite solution, and it may have no solution at all. This happens when rank of A not equal to rank of AB, the system has no solution. If rank of A equal to rank of AB, which is same as the number of variables, then it has unique solution. And if rank of A equal to rank of AB, but which is less than number of variables, then the given non-homogeneous system has infinitely many solutions. So we can move on to an example. So a system of linear equations is given: x plus y plus z equal to 4, minus 2x plus y plus z equal to minus 2, and x minus 2y plus z equal to 1. So this is a non-homogeneous system. So what are the steps? First, we need to write down the augmented matrix. What is the augmented matrix? What is augmented matrix?
First we write the matrix A and then the constants after the matrix.
Yeah. So it will be 1, 1, 1, 4, minus 2, 1, 1, minus 2, 1, minus 2, 1, 1. So this one is the augmented matrix, and the last column represents the constant term. So we have to separate it by a dotted line. Okay. The first column represents the variable x, second column represents the variable y, and the third column represents z. And the last column which represents the constant terms, that is the augmented matrix. Now you have to reduce this matrix into echelon form using elementary row operations. So we can apply R2 equal to R2 plus 2R1 and R3 equal to R3 minus R1. So this reduces to 1, 1, 1, 4. The next row will be 0, 3, again 3, minus 2 plus 8. That is 6. And the third row, that will be 0, minus 2 minus 1, that is minus 3. 1 minus 1, 0. 1 minus 4, that is minus 3. Right. So what are the next operations? Actually, you can see that in the second row, we can cancel the common factor. There is 3 as common factor, and also in the third row, there is a common factor. Minus 3. Minus 3 is a common factor in the third row. So we can cancel these common factors from second row and third row also. So we can change R2 equal to R2 times 1 by 3 and R3 equal to minus 1 by 3 times R3. So this becomes 1, 1, 1, 4, 0, 1, 1, 2, 0, 1, 0, 1. Now what? Is it in echelon form?
Yes, sir.
Is it?
No, sir.
No, it is not in echelon form. You look at the leading coefficients. The first leading coefficient is 1. The second leading coefficient is 1. Third leading coefficient is the second and third leading coefficient which comes at the same column. So it is not in echelon form. Or can we convert? What is the next step to convert it into echelon form? Usually we are doing what? Mark the second leading coefficient and make all the entries vertically down to it as 0 using the second row. So what will be the operation? R3 changes to
3 minus R2.
R3 minus R2. So that will be 1, 1, 1, 4, 0, 1, 1, 2, 0, 0, minus 1, 1 minus 2, that is also minus 1. So now this is in echelon form. Look at the leading coefficients. The positions are in increasing order. So the matrix is in echelon form. It is in echelon form. From this echelon form, this is actually the echelon form of AB. Okay, this is the echelon form of AB. And if you remove the last column from this echelon form, you will get the echelon form of A. So if you are removing the last column 4, 2, minus 1, that will be the echelon form of the matrix. Which matrix? Echelon form of the matrix A.
From
So we can actually find out the rank of A and rank of AB from this echelon form of AB. So what is rank of A? To find the rank of A, you have to look onto the first 3 columns only. You have to just remove the last column. And how many non-zero rows are there?
3.
3. Okay, so rank of A equal to 3. So what is rank of AB?
3.
That is also 3. So rank of A is same as rank of AB, which is same as the number of variables. How many variables are there? Totally 3 variables, x, y, and z. So which is same as number of variables. So the system has, if rank of A same as rank of AB, which is same as number of variables, then it has unique solution. Okay. Rank of A equal to rank of AB, which is same as number of variables. So the system has unique solution. So we have to find this unique solution. For that, we will use back substitution. That means we are starting from the last row. So what is the equation corresponding to the last row? That is,
minus z equal to minus 1.
Yeah.
Minus z equal to minus 1.
okay, you have to remember the first column represent x, second column represent y, third column represent z, and the last column represent the constant terms. So this R3 actually represents the equation minus Z equal to minus 1. So that implies Z equal to 1. So we got the value of Z. So move on to the second row. From R2, the equation corresponding to R2 will be
Y plus Z equal to 2.
Y plus Z equal to 2. So we know the value of Z. Z is 1. So that means Y plus 1 equal to 2. That means Y equal to 2 minus 1, which is 1. So we got the value of Z and 1. Now move on to the first row. So from R1,
Y
they
plus
give,
Z, X plus Y plus Z equal to 4.
yeah. So from R1, we will get the equation X plus Y plus Z equal to Z equal to 4. And we know the value of Y and Z. Y equal to 1 and Z equal to 1.
Equal to 2.
So X equal to 2. So we got that unique solution. This will be the only solution for the given system, and that solution will be X, Y, Z equal to 2, 1, 1. That is the solution. Okay. So the system has a unique solution because the rank of A is same as rank of AB, which is same as the number of variables. Okay. Is that clear for everyone?
Yes, sir. Sir,
Yeah.
could you suggest any textbook?
Textbook. Okay. One second. There is a textbook called CRASIC, Advanced Engineering in Mathematics. Okay. In this textbook, you can find a lot of exercise problems. Advanced Engineering in Mathematics, written by CRASIC. Okay. I can upload this textbook. If you need it, I will upload it in Teams also. Okay. Consider the next example. Here also a non-homogeneous system is given. So first thing we have to write down is we have to write down the augmented matrix. The augmented matrix of this matrix will be AB equal to 1, 2, 3, 1, 2, 1, 1, 2, 3, 3, 4, 5. That is the augmented matrix. Now reduce this augmented matrix to echelon form. So what are the operations?
R2 minus 2R1 and R3 minus 3R1.
R2 changes to R2 minus 2R1 and R3 changes to R3 minus 3R1. Okay. So this matrix will become 1, 2, 3, 1, 0, 1 minus 4, that is minus 3. 1 minus 6, that is minus 5. 2 minus 2, that is 0. And the next row, that will be 3 minus 3, 0. 3 minus 3 minus 6, that is minus 3. 4 minus 9, that is minus 5. And 5 minus 5 minus
5 minus 3.
5 minus 3, that is equal to 2. So now what? Now mark the second leading coefficient and make the below entry as 0. So R3 changes to R3 minus R1. So this becomes 1, 2, 3, 1, 0 minus 3 minus 5, 0, 0, 0, 0, 0, 0, 0, 2. Okay, now this matrix is in echelon form. Because I look at the leading coefficients. The leading coefficients are, the positions of these leading coefficients are in increasing order. So this matrix is in echelon form. And what is the rank of A? Rank of, how will you find the rank of A? Remove the last column from the echelon form. And how many non-zero rows are there if you remove the last column?
2.
2. So rank of A will be 2. And what is rank of AB?
3.
Rank of AB will be 3 because there are totally 3 non-zero rows in the echelon form of AB. So rank of AB is 3. Rank of A is 2, which is not same. So rank of A not equal to rank of AB. What is the meaning of that?
It has no solution.
The system has no solution. Okay. There is one more case we have to discuss. That is a case if rank of A same as rank of AB, which is less than number of variables. So the example for that case will be discussed on the next class. Okay. So you have to go through all these topics before coming to the next class. Next class will be on Monday. So there are so many days there for you to look after all the topics that we have already discussed. So you have to go through all these topics. Okay. I think from Saturday and Sunday. Okay. So we can start the next topic from the next class. So thank you, students.